Hello, my name is Jesus Valbuena. I'm doing this video to present my final project for the time series class at Depaul. As a data set, I have chosen the cryptocurrencies data set that I found on Kaggle that you can find using this address right here, where we have data or data sets for several cryptocurrencies. I was going to focus especially on the Bitcoin cryptocurrency and also Ethereum. The Bitcoin cryptocurrency I had chosen because of the recent decline, like sharp decline in prices that we can actually see right here. It starts at the end of 2017. And I was also going to use Ethereum, but I didn't get the chance to explore that because of the time constraint that we have for the project. So as an initial view of the data, I chose to post a few data points right here about the data that I'm using. So we have the dates for the time series data, and we have the closing value of that currency every single day since 2014 to 2018. So I did a little exploration of the data in order to get an idea of how the distribution of this data was happening. So basically I found out that the data was somewhat normal, with a little skewness towards the right. We have fat tails on the QQ normal plot, which means that we have a somewhat normal data, but it's not really normal. And we can see on the growth rate right here that we have variances in growth rate in 2015 and 2018. It's also interesting to note that we have a large number for the kurtosis of the data. So I proceeded to do an ACF and PACF analysis because I wanted to get started with the data by using AR and MA models, so the regressive models. And I found out that there was significant lags on the 5th and 6th position for the ACF and PACF models, which we can see right here and right here, which indicated the values that we would be using later when I created the models. So that was the next step. I basically created an IR model to do a forecasting and an IR model with the value of 5. And I found out that the distribution tended to go towards the mean when the forecasting was done, which we can see right here. And there is some variation at the beginning. Like if we could focus a little bit further on it, we could see the variation, but basically it converges towards the mean. And when I checked the residuals, I found that there was little normality for the residuals, which we can see right here. We had fat tails on both sides. And there was some dependence on the residence, some time dependence, which led me to believe that the model wasn't great, but it was the best so far when I compared it to an ARMA model and to an MA model. I did a GARCH model as well, taking into account the fact that there was some volatility in the data because of the sharp decline that we have in towards 2017. We have a cryptocurrency that is very volatile. And we found that there was an arch effect going on when we checked the graphs right here for the returns, for the log return square, and the absolute value of the returns right here, which is very clearly visible. So I decided to use a GARCH 2 model because of this reason, and this gave as a forecast a sharp decline when using a t-distribution, a sharp decline, and basically a return towards the mean value, which happened also when I was using the AR model. When I checked the residuals, however, for this data, I found that there was very little normality, which we can see right here, and there was also time dependency for the residuals, which was not great for the model. But it was the best two models that I could find for the data on the restricted time that we had. So basically the conclusions that I got out of this experiment and this analysis was that both the volatility model, the GARCH model, and the AR model showed values for forecasting that tended towards the mean, that converged towards the mean. The model significance was not great because of the behavior of the residuals. So it would be interesting to try different models on this analysis. And it would be especially interesting to try different cryptocurrencies, and we do the same analysis that I did for the Bitcoin data on Ethereum or Darch or IOTA or other different types of cryptocurrencies, to be able to compare the volatility or see if there is a seasonality that is more pronounced in the other cryptocurrencies than there is in Bitcoin data, which really, when I checked the seasonality of this data, it seemed to not be present. So that's the conclusion for the analysis. Thank you very much for watching.